What if all nukes were launched at the moon? Not one nuke, not a test, not a single warning. Every nuclear weapon humanity has ever built, fired at the moon, all at once. Would it crack the moon in half? Move the moon? End life on Earth as we know it? Let's find out. Right now, the world has roughly 12,000 nuclear warheads. Estimates usually land between 12,000 and 12,500, depending on how reserves are counted. Some of these weapons are relatively small. Others are powerful enough to erase entire cities. Together, they represent the most destructive technology humans have ever created. First, we need to know how much energy we're actually dealing with. If you add up the explosive power of every nuclear weapon on Earth, the total comes out to roughly 6,000 to 7,000 megatons of TNT. That number is hard to picture, so for comparison purposes, the atomic bomb dropped on Hiroshima was about 15 kilotons. That means all nukes on Earth combined are roughly 500,000 times more powerful than the bomb that destroyed Hiroshima. So yes, by human standards, this is an absolutely insane amount of energy. But space does not measure power in human standards. For example, the asteroid that wiped out the dinosaurs released an amount of energy comparable to around 10 billion Hiroshima-level bombs. And there's also a crucial difference in how that energy was delivered. Nuclear weapons release energy outward in a flash. Asteroids deliver energy inward, slamming into the surface at tens of kilometers per second and dumping that energy deep into solid rock. The moon itself was shaped by impacts even larger than that during its early history. So while 6,000 megatons sounds like a lot to us, it's barely a scratch compared to the kind of energy that space can throw around. Now, let's compare all that energy of all nukes detonating on the moon to the moon itself. The moon is almost 3,500 kilometers wide. It weighs about 73 billion trillion tons. Holding all of that together is gravity, and gravity on that scale is incredibly strong. To actually split the moon apart, you'd need enough energy to overcome its gravitational binding energy. That number is so enormous that all nuclear weapons on Earth fall short by millions of times. Even if every warhead detonated perfectly on impact, even if none failed, even if they all hit solid rock, the moon would still be completely intact. This is not a planet killer scenario. It's not even close. It's closer to someone trying to blow out a house fire. But what would this explosion of all nuclear bombs exploding on the moon look like from Earth? It'd look strange, bright, and unsettling. The moon would suddenly flash, not once, but thousands of times. Bright points of light would appear across its surface. Some would be visible on the near side, others would happen on the far side, hidden from view. The flashes would be brief, sharp, and uneven, like a storm of camera flashes going off across the moon. There'd be no massive fireball expanding outward, no glowing cloud wrapping around the moon. From Earth, it would look like the moon briefly glittered and then returned to normal. If you blinked, you might miss it.
Mommy, look at the moon! There's nothing there, sweetie.
Watching on the moon itself, this experience would look far more violent than watching it from Earth. There's no air on the moon, no wind, no pressure, no atmosphere. That changes everything about how explosions behave. Each explosion would create a blinding flash and extreme heat. The ground directly under it would instantly melt, and some of the rock would be turned into gas. That broken up rock and dust would spray outward in every direction, quickly spreading out and fading away into space. Instead of mushroom clouds, you'd see spherical bursts that fade in seconds. Molten rock would rain back down across the moon. Lighter material would escape into space. There would be no rolling thunder, no echo, just brief violence followed by silence. And anyone on the moon would likely not survive the blast, let alone the radiation.
Oh, why did you put me on the moon?
After the dust settles on the moon, every explosion would leave behind a crater. Some would be a few hundred meters wide. The largest might approach a kilometer. The exact size would depend on the nuke's energy and impact angle. But here's the key detail that changes everything. The moon is already covered in craters, millions of them. Some are tens of kilometers wide. Some were formed by impacts that released far more energy than all nuclear weapons combined. Compared to those scars, nuclear craters would be relatively small. So, does the moon move or break? This is the part people usually expect to be dramatic. Fortunately, it's not. Even if every nuclear weapon detonated at the same time, the moon would not break apart. It wouldn't split. It wouldn't drift away. It wouldn't suddenly move closer to Earth. No glowing cracks crawling across the surface. No global fractures splitting it open. No rivers of magma spilling out into space. The reason is simple. Momentum matters. The moon's mass is so large that the combined force of all nuclear explosions wouldn't move it. At most, the change would be millimeters. It'd be more like trying to push a cargo ship by blowing on it. The moon might experience small seismic vibrations. Shockwaves would travel through its interior. But those waves would fade quickly, just like moonquakes triggered by meteor impacts. Within hours, the moon would be calm again. Still orbiting, still stable, still there. So, back to Earth. Would we feel anything? Physically, almost nothing would change. The moon wouldn't shift enough to affect tides. Earth's orbit would remain the same. There'd be no earthquakes triggered by lunar movement. No sudden climate changes. However, there would be some subtle effects. Radiation from the explosions would most likely dissipate into space. A small amount might reach Earth, but not at levels dangerous to life. By the time it crossed nearly 400,000 kilometers of space, it'd be diluted to levels barely above background radiation. The distance is simply too great. Some debris kicked up by the explosions might remain in lunar orbit for a short time around the moon. A tiny fraction would escape orbit and make its way to Earth as micrometeorites that are barely larger than a pebble or coin. Lunar exploration would become more complicated. Certain regions of the moon might become hazardous due to residual radiation, though even that would fade over a 1-year period of time. The real long-term change would be symbolic. This event would prove something important. Human weapons, no matter how powerful they feel, are still small compared to planetary bodies. The universe operates on scales far beyond us little humans. So what if all nukes were launched at the moon? The sky would flash, the moon would gain scars, but the moon would survive. Earth would remain safe, and life would go on. In the end, the most unsettling part would not be the damage to the moon. It'd be realizing that humanity's greatest weapons are still tiny on a cosmic scale, and that the universe is far more durable than anything we can throw at it. That wasn't so bad. Nothing happened to the moon, and the Earth wasn't even affected.